Okay, guys. So let's start today with the chapter CSWIP 3.1 course, section 10, which is chapter 10, basically introduction to welding processes. So this is I cannot stress the importance of this chapter. The chapter is the most important chapter in the entire curriculum of CSWIP 3.1, because obviously we are going to be welding inspectors. That means we need to know welding process very thoroughly, as much as possible. If you can go, don't depend on 3.1 material, but you go online and check the videos on welding. There are so many videos made by very good people, especially Americans, in their garages, and a lot of videos have been made on this, and you can go and see those videos. You need to have the knowledge as equal to as welder, if not. And I have always encouraged people to do hands-on welding and learn the process completely, so that you will know the nuances and various issues on the welding, so that you will understand welding better. Then obviously you will understand defects very well. So in West, actually, especially in America and all the places, a welding inspector is usually an ex-welder. So he has a lot of experience on welding. Whereas when it comes to India, we are doing this, very bookish and very only on the paper, and we hardly have any welding knowledge. Like for example, in NDT level 2 and level 3, we are supposed to do practical and learn the trade ourselves. But in welding, it is not like that. Welding inspector's course doesn't require you to do one sample welding. That is the reason. But the thing is, to learn welding very well is very important. So you can go and read the chapters, books on welding, who is written by a lot of people who are renowned in welding field. So introduction to the welding process. Common characteristics of the four main arc processes are MMAW, TIG, MIG, MAG, and SAW. So this is the base. The welding process are four types. Usually in MMAW, which is same as SMAW, is a manual welding with electrode. TIG is the welding used with TIG torch, and usually called GTAW also. MIG MAG is basically FCAW and GMAW process, and SAW is submerged arc welding. Everyone knows that is semi-automatic process. So an arc is generated when an electrical discharge occurs at the gap between electrode and the parent material. So what they are doing is they are taking AC voltage and putting a transformer, and that transformer is converting AC into DC voltage, and then it is filtered, and then the filter is again made a couple of filters passed through another transformer if required, and then it comes out in welding machine as positive and negative. And negative is always given to the workpiece, and positive is always taken in the electrode and hand. And then of course the welding is when the negative is attached to the workpiece, and if positive voltage is in your positive current, or let's say positive terminal is in your hand to which an electrode is connected, and if you try to go together and now don't touch, just a little bit away, and you will see the arc will be generated, and which will heat the temperature will be so high that it will heat and melt the material or metal, which is basically used in the fusion welding process. So that's why it's called as fusion. We're trying to create an arc between the material and the electrode, and basically the electrode is also the same material as what we are going to weld, and then the welding happens. Basically welding is a lot of skill, which we will learn in this chapter. So the discharge occurs a spark to form and cause the surrounding gas to ionize, and the ionized gas enables the current to flow across the gap between the electrode and base metal, thereby creating an arc. So this is the electrical technology with which the welding was started. The arc generates heat and for fusion of the base material, and then with the exception of TIG, Heat generated by arc also causes electrode surface to melt, and molten droplets can transfer to weld pool to form the weld bead or weld run. Heat input to the fusion zone depends on the voltage, arc current, and welding travel speed. So please learn how the welding electrode is made, how the welding machine is made, what is inside the welding machine. All this you should know very, very clearly and thoroughly, so that you know what happens after getting CSWIP 3.1. Also, you are going to come on site, you are going to work here. Also, you are going to go to a lot of interviews. There they will be asking you counter questions. So your base need to be very thorough. So do a bit of research on this topic. Don't depend only on the CSWIP 3.1 notes. This is just to created to give you the basic input, and you should always learn more than that. Productivity with most welding processes, welding in the flat 1G, 2G position, resulting in highest weld material deposition rate and therefore productivity. From consumable electrode welding process, the rate of transfer of molten metal to the weld pool is directly related to the welding current density. So ratio of the current to the diameter of the electrode. So for TIG welding, the higher the current, the more energy there is for the fusion. So the higher the rate at which filler wire can be added to the weld pool. So in the TIG process, we have seen that the electrode is negative, and that is the reason that it has a higher, it has a deposition rate, but basically because of the skill of the welder, the process is a bit slow. But TIG is the only process where the consumable is not, the electrode doesn't burn. The electrode remains static, whereas you are giving a filler wire and filler input to the welding process. So if anybody has seen, I will just try to show this in pictures. Productivity is very important. So when we go to the site and start observing people, productivity will be very important parameter, which may not be the part of our scope of work if we are going to become an inspector, but we should always know that which process is most productive and which process is least productive. Why? Because sometimes we may be able to, we may be deciding these things when we become QC engineer or we become manager level, then obviously this is becomes very important. So the concept we should learn and try to observe that in the site as well. Heat input. So arc energy is the amount of heat generated in the welding arc per unit length weld, and is usually expressed in kilojoule per millimeter. So you know this arc energy is very important, and we will be using this a lot in our work. So please be very thorough with heat input, because what happens when we do the PQR, when we do the WPS, everything fine, tested in the lab, fine. When it comes to production welding, we are going to do weld audit, and I'm going to make one session for weld audit. In that, I will, be showing how to calculate the heat energy using this same formula with live examples and also on a video. So, and also a weld audit sheet. So that will be more thorough for you as a knowledge, but right now we are learning this as a part of chapter. So as when my video on this will come, you can watch it and learn more. So heat input for arc welding is calculated from the following formula. So arc energy kilojoules per millimeter is equal to volt into amperage divided by travel speed, millimeter into second, millimeter divided by second into 1000. That is the whole formula based on which we will derive the arc energy. So heat input, and why we are requiring to find out the heat input, because it is very important in the welding terms to find the heat input, because it should not go beyond the specified parameters. Otherwise, there will be a lot of issues with the welding. So heat input is the energy supplied by the welding arc to the workpiece and is expressed in terms of arc energy and thermal efficiency factor. Thermal efficiency factor is the ratio of heat energy into a welding arc to electrical energy consumed by the arc. So heat input values into the weld for various processes can be calculated from the arc energy by multiplying by the following thermal efficiency. So this efficiency factor you must remember throughout your career. Very important. For SMAW process it's 0.8. So this is directly telling you how efficient the welding is. So if someone will ask you whether the TIG is efficient or SMAW is efficient, you can tell them that TIG is the having efficiency as only 0.6, whereas MMAW, which is SMAW, has 0.8 and SAW has 1. So it is the highest efficiency. So straightforward, there will be questions on this in your exam. So make sure that you remember these efficiency factors. So let's see an example. A weld is made by using mag welding, which is FCW or GMAW process, and following welding conditions are recorded. So voltage 24, amps 240, travel speed 300 per minute. I'll tell you how to calculate this. So how you will calculate voltage and ampere? You have to go with a tongue tester, which is multimeter, to the welder who is doing the welding. When he will start the welding, you have to take the tongue tester and measure this very close to his cable, which is using the electrode. So if the welder is welding, that time his holder will be having electrode little bit 2 feet away. You can measure this voltage as close to his welding as possible. So you will get from there amperage and voltage. You can get from the welding machine also, or you can get from the same place. You can put it at amperage, you will get amperage, and same time you turn the knob to volt and you will get the volt. And then when he will start welding, you can take a clock and measure the how much he has done welding. So if he is doing welding 100 mm, then you can always divide that 100 mm divide by 60. So you'll get the travel speed. Or if he does 300 mm, 400 mm, you can divide by 60 and get the travel speed. So with this base in your mind, you can put the values in this formula and come out with the arc energy, which will be usually in kilojoules per millimeter. So you have put 1.1 kilojoules per every millimeter of the thickness or length, and then it has got welded and fused. So based on this, the heat input is 1.2 into 0.8 is 0.96. 0.8 why? Because it is the efficiency for GMAW. So 0.96 will be your will be your heat input. So heat input is mainly the chief benefit factor for the heat input will be travel speed. So if you go too fast, the heat input will come low. If you travel very slow or even medium speed, the heat input will be higher. So we don't want that issues in the welding. So that's why we are calculating this or trying to find out. So welding position and processes have major influence on the travel speed. So let us see what are the influences. Vertical progression tends to give highest heat input. This is the most asked question in CSWIP. So you must remember vertical up when you are welding. When you will be doing vertical up welding, there are many cases. For example, you are doing beam welding and you may be welding the web of the beam, or maybe you are doing pipe welding and you are coming from down to up, can be vertical up progression. Same way in pipe, you can go vertically down also. So that is also lowest heat input. So vertical up is highest input, vertical low is lowest input, so heat input. So this you can remember very, very well. Horizontal and vertical welding is relatively low heat input welding position, or because welder cannot weave in that position. So the weaving is becoming very difficult. Overhead welding is the low heat input because one needs to use low current and relatively fast travel speed. Nobody wants to do overhead welding for a long time. So he will try to do it as fast as possible. because the welding is falling on his face. That's why he will do it fast, and that heat input will crash or become less. So welding in flat position downhand can be low or high input because of the welder's position has more flexibility about the travel speed that can be used. So of the arc welding processes, SAW has the potential to give the highest heat input. Why? Because it's in 1G position, and it's also in the constant, also it's also it's spinning. Sometimes the pipe is being rotated or the arc is traveling. SAW has the potential. So it has the highest deposition rate also because of this high heat input. TIG and MMAW, MIG-MAG can produce very low heat inputs also. Typical heat input values for controlled heat input welding will tend to be between the range 1 to 3.5 kilojoules per millimeter. This you must remember, that heat input typically will vary between 1 to 3.5 kilojoules. Then let's see arc voltage. So arc voltage is related to arc length. For processes where the arc voltage is controlled by power source, SAW, MIG-MAG, FCW, it has a huge power source, can be varied independently from the current. Voltage setting will affect the profile of the weld. As welding current is raised, voltage also need to be raised to spread the weld metal and produce a wider and flatter deposit. So you will see many times you adjust the current, voltage will take care of itself because both are related. For MIG-MAG, arc voltage has a major influence on droplet transfer across the arc. So if you study MIG and MAG process very carefully, there is a droplets, spray droplet size type. When we are doing the welding, the electrode will fall into the weld pool by way of transfer, spray, droplet, these kind of mechanisms. So arc voltage is important. So welding current is a major influence on the depth of fusion, penetration. So that is why we will say if you are having the electrode negative, you will have higher penetration, electrode positive, medium penetration. That is why welding current is very important. So current has a major influence on the depth of fusion and penetration, he is telling. So base material and adjacent weld length. So as a rule, higher the current, greater the depth, because more current means more electron, more ionizing, more heat, and that's the reason more penetration. So penetration depth affects dilution of the weld deposit by parent metal, and it is particularly important to control this when dissimilar metals are joined. Yes, when dissimilar materials are joined means when stainless steel is welded to carbon steel, when carbon steel is welded to something else, penetration depth will have the dilution factor for both the materials. Now polarity. Polarity is also very important. Polarity determines whether most of the arc and the heat is concentrated at the electrode surface or surface of the parent material. So depending on where the polarity you will give a negative terminal to the work, which means the material to be welded, then here in your hand the electrode will become positive. So if you have positive in your hand or negative in the material, or negative in your hand, positive in the material, both ways it depends. Polarity will differ and the welding will differ. So the location of the heat with respect to polarity is not the same for all process and affects positions of options for each of the main arc welding processes are summarized as below. So let's see, this is very important subject and very critical thing to understand. So in SMAW manual welding, DC positive has best penetration and DC negative less penetration but higher deposition rate. So when a welder wants to do welding fast or welding he wants to finish the job fast, he will make DC negative. So be very careful. You have to be all. This is a very essential variable. So in the welding you will need to check this. AC not suitable for some electrode, minimizes arc blow. So AC and DC, you go to YouTube and check why they are not using the AC for welding. AC can be used for welding also, but the thing is that in DC, the electrode or the sine wave, in AC there is a sine wave, so there will always be a positive negative loop, and that's the reason there is a lot of generation of spatters in that welding, whereas which is start stop, whereas in DC it is completely cured uh, wave and has a linear wave and has the best penetration possible in DC negative. But the thing is, the welding is always done in DC positive. There is some exception to this rule. I have seen most of the time 7016 electrode you used for the root pass is always used with electrode negative, which is negative, and they are putting positive to the workpiece. And then once the root pass is over, they are switching the polarity to negative. They are giving it to the material to be welded, and positive they are starting hot pass with 7018. So between 7016 and 7018, these are the two important relations, correlations. Although 7016 you can also weld with DC positive, but I've seen as a a rule of thumb, or let's say practice, whether I don't know whether it is good or bad. You can write to me. But what I've seen, most of the WPS have 7016 negative and then 7018 positive, and that is the SMAW joint. TIG rarely used due to tungsten overheating. So it is tungsten will overheat if it is DC positive, and used for all metals except aluminum and aluminum alloys, and magnesium and magnesium alloys. So it's in DC negative. Required for AI and AI aluminum and aluminum alloys to break up the refractory oxide film. So we'll not talk about aluminum welding because we generally not have no experience with aluminum welding. But remember, the polarity is different for carbon steel and aluminum. So GMAW, if it is a solid wire used, then it's a DC positive used for all the metals, virtually all situations. Negative never has been used for the welding, and AC also it is not used because of this problem of sine wave I told you. Then FCAW, which is gas shielded and self shielded core wire. There's two different type of electro welding in that FCAW. One is called gas shielded. Gas shielded means if you are using CO2 gas as shielding, whereas you don't need to use gas. Also, there is, or you can do welding with FCAW, which is called as self-shielded. Self-shielding wires are also available, so you don't need to use gas, but the electrode is, or the filler wire is expensive. It is almost twice expensive as normal FCAW. But you can save the gas. You can make it more portable. So that gas can also save environment basically. So most common is DC negative positive, but with some proportional basic flux wires are designed to run on negative also. Some metal core wires may also be used on negative, particularly positional welding. So depending on the position, sometimes the welder may put it in negative mode and use it. SAW will give you the best penetration if it is on DC positive. Less penetration but higher deposition rate. Yeah, higher deposition rate if you are putting it DC negative. Used to avoid arc blow, particularly for multi-electrode system. For example, what is multi-electrode system? For example, in our company, we have a machine which has two SAW wires in two different machines, which is coming together and becoming one joint. So if I want to do welding of a very big, thick welding and also linear welding, I will use that machine. It has two SAW electrodes coming. So two filler wires are coming in that. So that in those systems AC may be used. So this is very important. So when you learn welding machine, what is inside a welding machine, how the welding machine is made, go and see the video on that. You will be more intelligent, and then you come to this table, you will understand a little bit better. But if you only read this much, then it is not going to solve the problem. Basically, welding needs more reading and more watching videos to understand welding very well. Then comes the power source characteristics. So how should be the power source? To strike an arc, a relatively high voltage is required to generate a spark between electrode and base material. That's what we know. So this is known as open circuit voltage and is typically 50 to 90 volt. So this is what I'm saying, open circuit voltage is many times it's called OCV. OCV machines are used as a common practice. Once an arc has been struck and stabilized, there is a relationship between arc voltage and current flowing through the welding circuit. That depends on the electrical characteristic of the power source. It's also we discussed in the past page, earlier page. This relationship is known as power source static characteristic, and power source are manufactured to give constant current or voltage characteristic. So you must know this OCV issue and also the constant current what we need for doing welding. So please study more about the power source, watch more videos so that you will understand what kind of power source is made for the welding machines, especially FCW, SAW machines. Constant current power source. So this is preferred type of power source for manual welding. And you know, still in this industry, about 50 to 60% of the welding is done by manually only. Manually means with electrode. So the volt amp characteristics for constant current power source is known in the figure, is shown in the figure 10.1 and shows that no current position, the OCV, and this forms this point. There are arc voltage current curves that depend on the power source for various current settings. So you have a chart here basically where on one side there is OCV is there, arc voltage, and on one side current is there, and this relationship is shown here. Typical volt amperage curve. This is voltage versus current, so it's called volt ampere curve. For constant current machine, this is the curve given, whereas if you go to welding machines, they will give you this curve for all the kind of welding machine when you buy. So for manual welding, MMW and TIG, the welding sets required current on the output on the power source, but arc voltage is controlled by arc length the welder uses. So the welder has to work within the fairly narrow range of arc length for a particular current setting. If it is too long, the arc will extinguish, and too short, and the electrode may stub into weld pool and arc is extinguished. So this is basically the training of the welder. If he goes very near to the metal, then the arc will become so high that welding will become distorted, or very fat bead will be happening. And if he will stay a little bit away from the welding surface or bevel surface, then his arc will extinguish, or he will be able to have a lot of start-stop issues. Many times this is also called as stick out or stick distance or something like that. For the operating principle of this type power source, see figure 10.1. So that's what is the graph for that. So for the welder tries to hold a fairly constant arc length B in figure 10.1. So let's see, this is the B. Okay, so if you see, if he's going to A position or C position, the current also changes. So let's see what happens here. For the current Y that has been set, however, he cannot keep the arc length constant and will vary over small working range between A and C due to normal hand movement during the welding. So any welding, it will happen, it you will have to you don't have much flexibility in that. You have to vary from A to C during the welding. Beyond this, if you go, it will extinguish. And below, if it is you go, then it will have too much welding heat in the job. The power source is designed to ensure that these small changes in the arc voltage during normal welding will give only small changes in current. Thus, the current can be considered to be essentially constant and ensure that the welder is able to maintain control of the fusion. And that's why when you are moving within the same range, you are almost on the constant current zone, and that's why it's called as constant current voltage machine. Okay, the drooping shape of the volt curve has led to constant current power source sometimes being called as drooping characteristics. Just because it is coming down like that, it's called as the drooping curve. So when you will do manual change in the hand movement during the welding, you can see here XYZ, there will be very small change in the current. That is why in our WPS, the current range is given, and that within the range we have to be, and that is the reason because of this. And because of this only, they are designing the machines which are constant current type. So let's see constant voltage type power source. So this is a preferred type of power source for welding process that have wire feed mechanism. So if you have FCW, SAW, GMAW, there all these kind of semi-automatic process, you need constant voltage power source. So this too a very important lesson you have to remember today for rest of your life. If you are doing manual welding, constant current type, because there is the characteristics required. Then for semi-automatic processes, it is constant voltage type. So wire feed speed and current speed and all are directly related to the current increase. So does the feed speed. So when you press the button and the electrode comes out, or the wire comes out, FCW wire, that is directly converting into current, and that is the reason it is constant. And this is also, then the voltage gets adjusted to this. So related to current increase, so does the feed speed, and there is a corresponding increase in burn off rate to maintain arc length voltage. The operating principle of this power source is shown in figure 10.2. Welder sets voltage B and current Y on the power source. If arc length is decreased to C, as you say, because of during the welder movement, there will be momentary increase in welding current to Z. So it's what here you can see. If you ABC, if you make the changes here, there is a wide change. You can see that was a narrow one. It is a large. Current is changed too much. So, and you can see this is not a drooping curve. This is almost like a straight line. Okay, higher current set gives higher burn off rate, which brings arc length and arc voltage back to the preset value. So similarly, if arc length increases, the current quickly falls to X and the burn off rate is reduced, so that arc length is brought back to the preset level B. Thus, although the arc voltage does very little during the welding, changes in the current that restore the voltage to the preset value happen extremely quickly, so that voltage can be considered as constant here. So in this is here the current will increase and here the voltage will increase. So during the welding, whatever change you make will have a little bit big impact on the current. Straight line relationship between voltage and current and relatively small gradient is why type of power source is often referred to as having flat characteristics. And since it is not drooling, it is flat here, almost straight. That's about the welding process and welding machine characteristics. So let's go through the slides. It's not much to be having there basically. So pressure welding is regarded as a joining process in which workpieces are in atomic contact, pressure welding, and what is pressure welding and what is fusion welding. So one must know this, and that is the reason why you read all these slides very, very well. The 4 essential factors for fusion welding. Fusion welding is achieved by melting and using high intensity heat source. Welding process must be capable of removing any oxide and contamination from the joint. Atmospheric contamination must be avoided. Welding joint must possess mechanical properties required by the specification being adapted. Then welding process. What kind of welding processes are there? Welding choice of welding process, joint property, welding position. So which one is good for what? Then non-fusion welding processes, because there are certain other welding processes also, because now the technology is improving a lot. Then welding process comparison between manual TIG, MIG-MAG, sub-arc, and which is SAW, and some electroslag welding. So this, you please understand this and try to remember, very important for the exam. And then we will meet in chapter 11, manual metal arc welding, which is SMAW welding.